Today we are going to continue talking about parallelograms, but we are going to focus on using the properties to tell us how to write the equations and therefore how to solve for missing variables. So before we begin though, let's make sure that we review our properties of parallelograms. So we know in our parallelograms that there are 5 properties that are true. So once I've drawn my diagonals, the first property I know is that the diagonals bisect each other. So that means for each separate diagonal, the 2 halves are congruent to each other. Not all 4 pieces, but those 2 halves. I know that consecutive angles are supplementary. And I know that opposite angles are congruent. So when we're differentiating between that, consecutive angles would be ones that share a side. Opposite angles are ones that are across from each other connected by a diagonal. I know that I have opposite sides are congruent. And finally, the last thing I know is that opposite sides are parallel. And I use an arrow to note that. And that doesn't give me any information for solving, but it does allow me to know that I have a parallelogram. So when I am looking at these problems, notice that all of these are inside the shape and many of them have a degree sign. So that means I'm dealing with angles. So before I can really do much of anything, I need to know what property am I working with. Number 1 here is that opposite angles are congruent. Number 2, I have, once again, opposite angles are congruent. Number 3, these share a side, and because of that, I can say that consecutive angles are supplementary. And on number 4, these share a side as well, which is why I would say here that consecutive angles are supplementary. So when I'm going to solve, anytime I have something that is congruent, and that's our squiggle over equal sign, that equation is set up as A equals B. Anytime that I have something that is supplementary, that equation is set up as A plus B equals 180. It is very important that you know the difference between these two because we will be using these facts all chapter long. So there won't be a moment where you don't have to know this in chapter 3. And we've talked about congruent in chapter 2, but we want to make sure that we're really solid on setting up these equations. So since opposite angles are congruent, I'll take my question mark, I'll call it x, set it equal to 119, and there's nothing left to solve for, and so x equals 119, and that's that measure of that angle V. For number 2, once again, opposite angles are congruent, but now we have something to solve for. So I'm going to say 82 equals 12x plus 10. Then I'm going to go ahead and solve my equation. So I'll subtract 10 from both sides. I get 72 equals 12x. When I divide by 12, x equals 8. So if I wanted to find the measure of this angle, I could plug it in, but all I'm looking for is to find that value of the missing variable, which is x. The next problems are supplementary. So no longer will we set the 2 angles equal to each other, but we'll take the 2 angles and we'll sum them to equal 180. And then from there, we will go ahead and solve. So my goal is to get x by itself. I have a one-step equation. So when I subtract, I get that x is equal to 99. Same type of thing is going to happen on the next problem. I'll take that 95, set it equal to 10x plus 5, and solve. So my final answer here is x equals 9. And these are how we will solve problems when we're dealing with either opposite angles or consecutive angles. Now, when we're dealing with diagonals, our property tells us that the diagonals bisect each other. So remember, bisect means to cut in half. And if you cut something in half, no matter what, it's going to end up being congruent, which means that anytime we solve these problems, we're going to be looking to somehow use the fact that we set the two halves of the diagonals equal to one another. Before we begin, though, we really need to pay attention that we are using the correct diagonals in the correct pieces. So I like to start off by saying WS is 6. So right there, I know that that's going to be 6. And then find WY. And WY, notice, is the whole length. So I would make sure that you have some colored pencils or highlighters in front of you so that you can also draw on your picture so you can visualize what's going on here. I know that this is congruent to this, and that's because I know that the diagonals are bisected, which means that the two halves are congruent. So if the WS is 6, that means that SY is also 6. So when I want to find the length of WY, that means I'm going to be looking at the sum of those, so that would be 12. Not all of these are going to have us having to take the sum of the two halves of the diagonal, but you're going to see a few different ways that these problems could be set up. For the next problem, I know that KE is equal to 17, so that's this half of the diagonal here. And then I want to find EM, and EM is just this half of the diagonal. So if I know that KE is 6, and I know that these two parts of the diagonals must be congruent, then it must follow that EM is also 6, and there's nothing else I need to do to show my work for this one, because I know that these two parts are congruent. These same rules will apply when we are solving for x and not just looking for a side length or a diagonal length. So BW, here I've highlighted it green, WD highlighted in purple. I know, because this is a parallelogram, that these two parts are congruent, which means I am going to take these two and I'm going to set them equal, and then I will solve. So using that information, I can then go ahead and move my x and move my constant. So I'm left with 1x equals 5. Let's look at the same type of thing for number 8. So HN is 15. And I know that LN is 2x plus 10. So notice that LN is the whole length. So I can't set these two equal because they're not equal. But I could figure out the length of, I know that ln is all of that, 2x plus 10. I know that this little piece right here is congruent to this piece, so both of those are 15. So if I know the whole length is 2x plus 10, and I know that each half is 15, I know that the whole length is also 30. So I could use that information and say 2x plus 10 equals 30. Then I can subtract 10, and I get 2x equals 20, so x equals 10. The last kinds of problems we have is that in a parallelogram, we know that opposite sides are congruent. If opposite sides are congruent, that means the sides that don't touch, so see how these sides don't touch each other, that means that they're congruent. All I do is set it equal. So x equals 23. Same kind of thing happens on the next problem. Because these do not touch, that means that these two are congruent. So I will take my x plus 2, set it equal to 2x minus 9, and solve. So subtract x, add 9, and I get 11 equals x. And that's my answer.